Hello viewers, you're welcome back to channel. So in this video, we'll be looking at conic sections, starting with parabola. So already in chapter 3 of this course, we discussed parabola. We discussed the analytic definition of a parabola. We said is given by ax squared plus bx plus a c, right? It's like quadratic. We now want to focus on the geometric definition of parabola. Now, for parabola, we have two important things. So let's just start. We said a parabola is a set of points in plane that are equidistant. So some words are very important here. Something like equidistance. We saw this in chapter 1. Points on a plane that are equidistant from directrix and focus, right? So if you look at my right here, we have a parabola. This is an example of a parabola. It's an open-up parabola. Now, what is the axis? We'll talk about that first. If you look at this parabola, on this parabola, you can see two things, which are very important. You can see there is a focus, and there is what? Directrix. So directrix is this line here. So if you take a point anywhere on the parabola, what this is saying is that the distance from this point, so this is our point, to this focus, call this focus F, and this line, call it D. So this distance must always be the same. So in other words, the distance between PF is going to be the distance between P and D. So this is always true for a parabola. So it doesn't matter where the point is. If you like, take another point here. If you take another point here, there is a distance, a vertical distance from this point to this this horizontal line, which is our directrix. And there is also a distance from here to the focus. So what is saying that this distance and this distance must be the same. Also, these two distances are the same. So for parabola, take any point on a parabola, the distance from that point to the directrix and the distance to the focus are the same. Okay, so now let's discuss what is this directrix and what is this focus. Okay, so if we have a parabola, there is always a line. They say there is a line that passes through the focus and is perpendicular to the directrix. That line is called the axis of symmetry. So like you can see in this case here, if you have this parabola here, so let me do with this now. If you look at this parabola here, there is a line, this line that divides the parabola into two equal halves is called the axis of symmetry. So, and this axis of symmetry will always pass through the what? It passes through the focus and it passes through the vertex. So we know what the vertex is. The vertex is just the lowest point or the highest point. So if you have an open, because we can have an open up, we can have an open down. So this is the vertex and this is the focus. So there is a line that passes through the vertex and the focus, dividing the parabola into two equal halves. And that line is called the axis of symmetry. Then it is perpendicular to a horizontal line called the directrix. Now let's discuss types of parabola. So here we'll start with the parabola where the vertex is at origin. So remember we said the vertex is either the minimum or the maximum point in a way. But that is based on our definition of chapter 3. But now we have more because we have two types of parabola here. We have what we call the vertical parabola, and then we have what we call the horizontal parabola. So a typical example of a vertical parabola is this one. So you see, this is an open up. We can also have what we have open down. So which will depend on the value of P, which we will discuss shortly. So like now, this is a vertex. The vertex is at 0, 0, right? And now you have to go a point P. If you go a point P up this point, then you will have what we call your focus here. So if you go a point P distance down, you will have the directories. And as you can see, these are points on the circle, on the curve. The distance to this point and the distance to this point must be the same. So this is in the case where you have a vertical parabola. The axis of symmetry is the y-axis because it is the y-axis that divides the parabola into two equal halves. Okay. And in that case, for vertical parabola, we have this equation, which is x squared equals to 4py. We have the vertex is at origin 0, 0. The focus, you can see the focus is where? Is on the vertical, is on the y-axis. So that is why, because the focus must be on what? It must be on the axis of symmetry. So our axis of symmetry here is y. And then we have the directories, which is just the line y is equals to p. And we have the focal diameter. The focal diameter is just the what? The focal diameter is, well, I say, yeah, you can say is the distance. You can call it the distance between. So we can just say it's the distance between this curve that passes through the focal, passes through the focus. So if you have this, if you want to find the focal diameter, it's just this distance here. So this is going to be 2p, and this is going to be 2p. So that will be a distance of 4p. Now, for here we have that if p is greater than 0, you have open up. If p is less than 0, it's going to be an open down. Now, in the case of the horizontal parabola, this is an example of horizontal parabola. So horizontal parabola could be open to the right or open to the left. So because you can also have something like this, all depending on what is the value of p. And it has this equation, y squared is equals to 4px. The axis of symmetry in this case is the x-axis. You have 0, 0 to be the vertex. You can see here the focus is what? P0, meaning that your P is on the x-axis. And because the axis of symmetry is the x-axis, and the directory is just minus P. And it's going to be open to the right if your P is greater than 0, and open to the left if P is less than 0. And we discussed this already. This is true for any point. If you have a point on the parabola, the distance between that point and the focus F is always the same as the distance between that point and D, which is the directories. So let's just take this example 1. Example 1 says we should find the axis of symmetry. So we start with the first one. The first, this is y, it's equals to minus of x squared. So all you need to do is we can rewrite these as what? So let's call this a. So this we can write it as x squared equals to what? Minus 2y. And then you compare with what? So you compare this. So you compare with x squared is equals to 4p what? 4py. And what does that mean? It means that you have a vertical parabola. Yes. And now you can see, you can just equate these two. If you compare with these, we will have that what 4p is equals to minus 2. And that means that p is equals to minus 2 over 4. So p is minus half. And now that is less than 0, right? And what does that mean? It means you have an open, it's going to be an open down parabola. All right. So now we want to find the what? We want to find all of this, the vertex. Now, what is the vertex? Let's start with that. The axis of symmetry. So let's say axis of symmetry. So if this is a vertical parabola, and you can see there's no, if it's a vertical parabola, the axis is going to be the y-axis, right? So our axis of symmetry is going to be the y-axis. And what does that mean? That means the line x is equals to what? X is equals to 0. And what is our vertex? Vertex is just 0, 0, because there is no any translation. Then the focus, all right. So what will be the focus? Now our focus is this. Let me just, you can even try to graph it directly. We know that this is going to be an open. So let's say you have something this way. Once we know our vertex, what is the vertex? We know this is vertex 0, 0, and it's going to open what? It's going to open down. So it means we're going to have something like this. Okay. All right, I'll talk about this now. Now, so this is our vertex here, which is our V, which is 0, 0. And once we know P, so what is P? P is minus half. So you just need to go a distance of you need to go a distance of P, right? So if you go a distance of P down here, we will have a point here. And what will be this point? This point is going to be our x is going to be what here? X is going to be 0. And what is y? Y is going to be minus what? Minus half. So that point will be our what? That point will be our focus. So this is our focus here. Okay. Then you also go a distance of what's of P. And that line, this point, if you look at this point, is still 0. And now it's what? It's 1. All right, so let's do this now. So you can see there will be a line. This line is our directrix, and you can see it's nothing but the line y is equals to what? R. Okay. All right. So now remember, this is our what? This is our focus. So let me just let me remove this first. This is our focus here. Now, since this is focus, is F. We talk about focal diameter, right? So we talk about focal diameter, and how do you do the focal diameter? The focal diameter is given by 4p. So let me write it here. Focal diameter, it's equals to 4p absolute value actually. So this is going to be 4 times what? Minus half, because p is minus half. And you can see that this will give us what? This will give us 2. Now, since the focal diameter is 2, all you need to do, it means you need to go a distance here. So if this is 0, so you need to go from here to here, it's what? It's 1. So you need to go a distance of 1 to the right. If this is 0, so you have to come here. This is going to be 1. So you draw a point here, right? And then here you also go here. This is going to be minus 1. So this is 1, and this is 1. Now you just need to draw your curve from your from the vertex, and you cut through this point and coming down, and through this point and coming down. So what is the importance of the focal diameter? It helps you to know how wide your parabola should be. So remember, we use the focal diameter of 2. So it means the distance from this point passing through the focal diameter, this one. This distance is what we call the focal diameter, and it's given by 2. So it helps you to know how wide the parabola should be. Okay, now let's just write down this, what we're asked to find. We're asked to find the focus. So clearly from the graph, you can see the focus is given by 0, what? Which is the focus here, which is 0 and minus half. And what is the directrix? The directrix is the line y is equals to what? 1 over 2. And what else again? We asked to find the focal diameter. Okay, so let's see, let's add the focal diameter, which we already talked about here. The focal diameter is 4p, and this is going to be 2. Right? Now, this one is the same thing as using the formula. Remember, the formula is going to be 0p, and this one is just going to be y. They have formulas, right? So you can use the formulas. So let's just write the formulas first. 0p, which is what? Which is 0 minus half. But you can do without memorizing the formula once you understand how the graph works. So, and the directrix is minus p, which is simply what? Y is equals to half. Right, so let's go with the second one. Now, where's the second one? So the second one, I would like to do it without memorizing the formula. So let's take the second one here. So the second one is this one. X is equals to b. Let's call it b. X is equals to 4y squared. Now, this, how can you write this? This simply means that what? This is saying that a y squared, it's equals to 1 over 4 x. And now this definitely is going to be a what? This is going to be a horizontal, because the square is on y, so this is horizontal parabola. Now, since it's horizontal parabola, another thing that is important is we can find our p. You compare with what? You know, we compare with y squared. So we compare with y squared is equals to 4px. And this means that 4p is going to be 1 over 4, right? And that means that p is going to be 1 over 16. And this is greater than 0, right? Since it's greater than 0, it means the parabola opens to what? To the right. So you have a horizontal parabola which opens to the right because of what? The value of P. Now, we know two things. We know the vertex is clear. So let me just, you start with the vertex. You can see the vertex is going to be what? 0, 0, because there is no translation for X and Y. So this is our vertex. And we know it's going to open where? Open to the right. So it means it's going to go something like this, right? Okay. But let's keep that for now. Now, since this is this, we know if you move a distance of P, what is our P? P is 1/16. So if I move a distance of 1/16 to the right, this point is going to be my focus. And that is going to be the what? 1/16 because we're on the x-axis and 0. And now we have to go a distance again of P. So remember, this is distance of P. So distance, we will be here. And this is going to be, which point is this? This point is going to be still on the x-axis. So this is minus 1/16 and 0. Okay. Now, it's opening to the right, so definitely this way. But now, another thing is look at our focus. This is our focus. Because now we need to know how wide we're going, right? So that is where the focal diameter comes into play. So what is the focal diameter? The focal diameter is just going to be 4 times what? Focal diameter is 4 times P. So this is 4 times 1/16, which is about 1 over what? 1/4, right? So it means you need to go a distance of 1/4. So if this is a 0, so you need to go a distance of 1/4, maybe somewhere here. So you can count this 1/4. And also, no, let's see. Okay, so this is, you need a total distance of 1/4, right? Yeah, so this is going to be about 1/8 and then 1/8 down. So you need a distance of about 1/8 and minus 1/8 here. So that will guide. Remember, you are doing this through the focal. So this is just going to be this one, something like this. And then you just drag it, keep going. Okay. And now this is going to be our what? This is going to be our directories. Remember, the directories is always perpendicular to our axis of symmetry. And then you can get whatever we want to get. Remember, this is our vertex. This is vertex here. Vertex is the origin. So this is V. And this line here, this is our directories, which is x is equals to minus 1 over what? Over 16. So let's just write everything down now. So axis of symmetry. So axis of symmetry is the line that divides the parabola into 2 equal halves. And you can see it's no other line but what? The line y is equals to what? The line y is equals to 0. Then we will have the vertex, which is clearly at the origin. Then the focus. Now, the focus, since we are on what we can see in the focus is already what? 1/16 and 0. So the formula is going to be what? P0, right? Which is nothing but 1/16, 0. And then we need the focal. Let's go with the focal first, the focal diameter. The focal diameter is a distance of 4P in absolute value. And that will give us 4 multiplied by P, what is P? 1/16. So this is just going to be 1/4. Remember, 1/4 is the focal diameter, right? So if you want to get the So let's say the distance from here to here, you can call it the focal radius. Yes. So from here to here is also another focal radius. So the two of them give you the focal diameter, right? So this is the focal radius. Okay. Then what else? The directories. The directories is given by x, it was minus p, and this is nothing but x is equals to what? You can see minus 1 over 16. And we're done. Okay. All right, let's see example number 2. Example number 2 is asking for us to find the equation of the parabola in standard form. Let's adjust this a little. Let's make this to be 0, 4, so that it will be different. Yeah. So find the equation of a parabola in standard form, which vertex is the what? Origin, and you have focus. So let's take A. The focus is what? Is minus 2, 0. And already we are told that vertex is what? It's the origin, so it's 0, 0. Now, all you need to do here is we need to know what type of parabola we are dealing with. But if you look at the focus, since the focus is minus 2, 0, and you compare with what? This is like saying the focus is what? P0, right? So it means the P is on the what? On the x-axis, right? So the P is on the x-axis. If you remember, the focus is always on the line of what? Of symmetry, right? So what means is that now our line of symmetry is the x-axis, right? So this means that you are dealing with what? You are dealing with a horizontal parabola. And since what? Since you can see P is what's on the x-axis. All right. So well, we know what is P. P is what? P is equals to minus 2. And we're done. So we know the equation is just going to be what? Y squared is equals to what? 4px. So all you need to do is to substitute what is p. So you have 4 times minus 2x. So y squared is just going to be minus 8x. Okay, then for b, we have the vertex. So let's see b, what did b say? B is 0, 4. Let's change it to 0, 4. 4, 0, 4. So it means we're using the focus to be 0 and 4. So if the focus is 0 and 4, all you need to do is to compare with what's. So this is going to be our P. So and this means that we are in the what? We are dealing with vertical parabola. When you are dealing with vertical parabola, it means your P is on the what? On the y-axis, right? The P is on the y-axis. So you can see P already is equals to 4. And now we can write vertical parabola, which is x squared is equals to 4p what? Py. This is for vertical parabola. And then we just have x squared. It's equals to 4 times 4 times y. Right? So x squared is just going to be 16y. So this is the equation in standard form. All right. So I think that is the end for this first part of this video. So this is how to graph a parabola with a vertex at the origin, and also how to find the equation standard form when you are given the focus. So thank you for watching. Watch out for the next video will be for shifted parabolas. I mean, when the vertex is no longer at the origin.